Hello, good morning everyone. Welcome to One Problem Per Day. So once again we are beginning, and before we start, happy Diwali greetings for all one and all. Hope you are all enjoying the vacations and stay safe. Okay, so let us begin with this. A ball of mass 0.8 kg is attached to a string. Okay, so distance to center of mass to the ball of the point of support is 95 centimeter. Okay, so we use a little bit. Okay. The ball is released from rest when the string is horizontal. Okay. When the string becomes vertical, the ball collides with a block of mass 2.4 kg. It hits over here. So what happens over here when it hits? So there is a collision. There is a collision. Then it rests on a horizontal surface. Okay. And then what happens over here? So the moment it goes and hits over here, this object which was at rest now starts moving like this. So this part of it is smooth until here, and after that is a rough surface, which means what? So from here to here, it will continue with the same speed because no external forces are acting. And after this, from here to here, in this region, this will slow down. It will slow down. Okay. Now, just before the collision of the ball with the block, what is it you want to do? Draw a free body diagram for the ball just before the collision of the ball with the block. So that means at this position, what is the free body diagram? Simple question. So since it's moving in a circular path, so you will have tension acting here, mg acting here before it hit over here. So as a result of it, I will not write any tension force, no, the normal force over here. So tension mg, and then this will be the acceleration. So this is centripetal acceleration. And this, now how many marks is this? For 2 marks. Okay, I need to draw here. So tension is acting here, mg is acting here, and since it was moving in a circular path, so I should be writing the centripetal acceleration here. This is for 1 mark, and then I will be writing P minus mg is equal to mac, which should be mv square divided by r, where v is the speed at this point. Okay, v is the speed at this point. So this will complete one free body diagram for this particular point. Okay, and next. Show that the speed of the ball is about 4.3 meter per second. So we need to find what is the speed of the ball at that point. So let me go back. So what was the height? The ball of mass 0.8 kg. So this is 0.8 kg, and this length is 95 centimeter. So this length is 95 centimeter. So if this is 95 centimeter, now I can use my conservation of energy formula. So at this point, the potential energy at this point was, let me say for example here, if I assume potential energy equal to 0, the kinetic energy here would be equal to half mv square, right? And if I consider the potential energy here, because you left it from rest over here, so you can say it had a potential energy is equal to 0.8 multiplied by g multiplied by 95 centimeter, which is 0.95 meters. And your kinetic energy was literally 0 because it was not having any speed. It was 0. So kinetic energy, which is half mv square, is 0. Now if I apply my conservation of energy, what do I get? So now I will write conservation of energy here itself. Conservation of energy, I will write potential energy initial, which is 0.8 into g into 0.95 plus kinetic energy initial, which is 0, is equal to potential energy final, which is 0, plus kinetic energy final, which should be half into m. What's the value of m? 0.8 into v square. So what will happen? This 0 anyway goes away. You have 0.8 and 0.8 goes away. If I choose the value of g to be 10, I will write this as g is 10 into 0.95 is 9.5 is equal to v square divided by 2, which means v square equal to 2 into 9.5, which will be equal to 2 9s are 18 plus 1 19. V should be root 19. Okay, now let me take this value and put it over here. So I will write v is equal to square root of 19. Let me find out what's that value of square root of 19 in the calculator. So this square root of 19, square root of 19 is 4.35. 4.3. So we have arrived at the right answer, 4.3 meter per second. Okay. Then determine the tension in this. How do I determine the tension in this thing? So look at the equation that I have drawn here. So it says P minus mg is equal to mv square by r, right? So therefore I need to plug in the value of V here. So I will write T minus 0.8 times G is equal to 0.8 times 4.3 square divided by radius. What's this radius? Radius is 0.95 meters. How do I know? Because the particle was at this point. This was now describing a circular path like this. So what will happen? This will be the radius of the circle, right? So when I do this, let us calculate this value. So this would be see this 4.3 square. Let's say 4.3 star 4.3 multiplied by 0.8 divided by 0.95 is equal to 15.57. Is equal to 15.57. Then okay, so you have got so much. Now what I will do is I'll write E is equal to 0.8 G plus 15.57. So when I use my calculator, this I already done this 15.57 plus 0. Plus 8. The 0.8 multiplied by G is 8. So when I do this, I get 23.57. So I write this as 23.57, which is 23.6 Newton. Okay, but you see here, how many significant figures should I use? This is a common question. Yesterday also I put one blog over here. So as you see here, this has 95, this is 2.40, 3 significant figures, 3, 3, 3 here. I can always replace this one only with 3 significant figures. Okay, so let me write it down here, and then okay, I'll written 23.6 Newton. Now there is one misconception which many of the students will do is that instead of using this equation, what they do is they directly consider tension is equal to mg. You can use this equation only when the particle is just suspended like this. So just suspended like that, then you can use T equal to mg. But when it is being dropped from here, it is undergoing a circular path like this, then you should say that T minus mg is equal to mv square by r, because there is a centripetal force acting over here. When it came at this point, did it have any velocity? It had some velocity. So as a result of it, okay, you should use T minus mg is equal to mv square by r. Okay, now let me move on to the next one. After the collision, the ball rebounds and the block moves at the speed of 2.16 meter per second. So that the collision is elastic. Now, elastic collision. So what do you mean by an elastic collision? Elastic collision is one wherein your COM and COE both are satisfied, both are correct, both are valid. Okay, so we need to verify it. That's it, to show them. So towards it, so first of all, COM. How do I find COM? What is COM? Conservation of momentum. So you have the ball here, and then this hit the object over here. The moment it hit over here, so what happened was it started moving. So find out what is M into V for this ball, and find out what is the M into V for this one over here. Okay, and you find out okay, whether the momentums are being exchanged. Okay, now what we have here, M into V. What was the M here? 0.8. 0.8 multiplied by V. What is the V over here? V value was V. The value was going to be 4.3. Let us write that also. Into 4.3. This was your momentum before collision. Let me write this as Pi. And momentum after collision. Now what happens momentum after collision? The block moves at the speed of 2.16 meters per second. And what is the mass of the block? Is it given? Mass of the block. Let us go back to this one here. There is ball of mass, block of mass 2.4 kg. Okay. Right. Now 2.4 kg. Take up this value. F is 2.4 kg multiplied by 2.16. Let us multiply these two. Now one condition that I have here is that when it hits here, there is a possibility that it hits here, this might go back like this, right? Because because the masses are different. So definitely I cannot expect this one to exactly come and stand here and say, hey, I have given all the energy to you, I'm going to stop it. I'm not going to do that, right? So I'm going to hit it, and there's a possibility that it may go back. Let us find out what is this value here. So let me use my calculator. 0.8 multiplied by 4.3 will give me 3.44. 3.44. And what is this? 2.16. And then 2.4. Now let us take up this one. 2.4 multiplied by 2.16. 2.16 will give me 5.184. 5.18. What's happening? Okay, so this is larger, this is smaller. So definitely, okay, so you cannot say that this is a conservation of momentum is not conserved, because any collision, conservation of momentum is conserved. But what is actually happening is that the moment it hits over here, this goes back like this. So what was the flaw here? The initial momentum was only 3.44. The final momentum should have been momentum of this plus momentum of this one. Momentum being a vector, I should now write minus m into v. I do not know what is this value of v here. Which v is this? The velocity at which it got rebounds backwards. What rebounds backwards, right? I do not know this. This value of m is known, but this value I do not know. Okay, I need to find out this. But we know from conservation of momentum, okay, pi is equal to p. I can directly equate this. I can now write 3.44 is equal to 5. I'll write this as 1.8 minus 0.8 times p. When I do this, what do I get? I get the value of v here. V should be equal to 5.18 minus 3.44 divided by 0.8. Let us calculate this value. So, have 5.18 minus 3.44 is equal to so much divided by 0.8. When I do this, I get 2.175. I make it 2.18. So 2.18. What is this now? This is the, I'll write V2 here. This is the velocity of the ball after it hits the block. Okay. Now, what did I say? The COM is already verified. You need not even verify, because the moment you say it's a collision, whether it's a elastic collision or an inelastic collision, it will always be COM is verified. Not worry about it. COE. Now, if COE is verified, then definitely your solution is correct. Now, what do you mean by COE? Conservation of energy. Now, what is the initial energy before collision? What we'll do is we'll write this as half into 0.8 into 4.3 square. This is your initial energy. What is this value? Let us calculate this value. This value would be, let's calculate this value. This value would be 0.8 multiplied by 4.3 multiplied by 4.3 divided by, you get this is 7.39 or 7.4. Approximate this. Take 7. Did I take up all the values? Let us say 0.8 into 4.3 into 4.3 divided by, yeah, I taken all this. So this was your initial energy. Let us take final energy. What's the final energy? Final energy is the energy of the block which is moving forward and energy of the ball which is going backward, right? So energy of the block. What was the energy of the block? Let us take the half mv square. What is the mass of the block? Mass of the block is 2.4. Mass of the block is 2.4. 2.4 multiplied by, what's the velocity of the block? So now take this 2.16. 2.16, which is given 2.16 the whole square. 2.16 the whole square plus half to, what's the mass of this block? 0.8. You know, you would have got a mistake by now. V, what is the velocity of the block? 2.18. Many of you would have been thinking, okay, why should I take this positive? It should be energy is negative, because it's going like this in the opposite direction. Why can't I take it negative? You cannot take it negative because energy is always positive. Right? Energy cannot become negative, so energy is always positive. So energy of this block plus energy of this block, because energy is a scalar quantity. Okay. So now let us calculate this value. I think it should come. Let us try. Okay. make me fail. 2.16 divided by 2. I got 5.598. I put this as 5.6. 5.6 plus, let us calculate this method. So this would be 0.8 multiplied by 2.18. This is square here. I made a mistake. 2.18 multiplied by 2.18 divided by 2. I get 1.9. 1.9. So how much is 6 plus 9 is 17. 1, 6, 2 plus 5, 7. 7.7 joules. Why did we make a mistake somewhere? The calculation is have been gone wrong. Okay, but check it out almost. Let's check it out once again here. 4.3 square multiplied by 0.8 divided by 2 half into square. 7.4. That's right. And here it is 2.4, 2.16. Somewhere I think this should be wrong over here in the case. Let us calculate this once again. Go back. Let's see whether we get it here. 3.44. What is 3.544? Oh, that one. Okay. So 5.18. 5.18 minus 0.44 is equal to how much? Divided by 0.8. 2.175, which is 2.18. That's fine. And 2.18 and 2.16, the whole square. This is, once again, 2.18 square is 4.7524 multiplied by 0.8 divided by 2 is 1.9. That's right. Okay, so closely. What is the question? So the collision is elastic. We should get this as 7.4 and 7.7. So almost close agreement. So hence we can say that the conservation of energy is seen to be valid, and hence the collision is seen to be hence. Okay, now let us look at the next question. Calculate the maximum height risen by the center of the ball. Maximum height risen by the center of the ball. Which means what? Which means what has happened? Let me keep it like this. Ball, it came here, it hit here, and the moment it here, what happens? So this will now go back like this. Okay. So actually it has dropped from here. It came all the way along here. It hit here, and immediately it went back. So what is this? What is this? How do we do this? Now, why should it go upwards? Because it had some energy. Where is that energy coming from? Because it gave only a part of the energy. Part of the energy it got from here. It retained, right? What was that energy? That energy was 1.9 joules. 1.9 joules was present over here. So 1.9 joules of energy was there as this kinetic energy, and then it started going upwards, which should now be equal to 0.8 into 10 multiplied by h. Right? When I use this, I get h is equal to 1.9 divided by 8. Which should now be equal to 1.9 divided by 8, which is 0.24. 0.24 meters should be raising to 24 centimeters. The maximum height it has gone upwards is 24 centimeters. Okay. Now let us move on to the next one. The coefficient of dynamic friction between the block and the rough surface is 0.4. Estimate the distance traveled by the block on the rough surface until it stops. Let me go back to the diagram here, and as you see here, from here to here, no problem. Okay, continue like this. Only here it slows down, or maybe it comes and stops here. You need to find out what is the velocity at this point. Now, how do you find? What is the velocity at this point? The velocity at this point was seen to be v equal to root 19. That's what we found out. It's 4 point. Is equal to 4.3 meter per second. And what is the velocity at this point? The velocity at this point is seen to be 0 meter per second. Okay. Now what else is given? Let us go back to the problem once again. The coefficient of friction is already given 0.4. Okay. So it's a dynamic friction, it's a sliding friction. So the frictional force is constant, which is given by mu times n. Right? What is the value of mu? 0.4. What's the value of n? M times g. What is this? 0.4 multiplied by what's the value of m? M value was already given 2.16. What is the velocity? What is the speed? What is the mass of the block? 2.4 kg. 2.4 kg. 2.4 kg multiplied by 10. Multiplied by 10. Multiplied. Oh, I thought it was division. Okay. Let us find out what is the frictional force. Frictional force is 0.4 multiplied by 2.4 multiplied by 10, which will be 9.6. 9.6. Now what happened? You can do it by two methods. I am doing by one of the energy methods. This was the block. This had a mass of m, which was equal to 2.4 kg, 2.4 kg, and a velocity. What was the velocity? Velocity. What was the velocity of this? It was a question paper. We have seen it directly. Velocity. What's the velocity of this block? Velocity of this block 2.16. That's all the given. 2.16. Now what happened to this kinetic energy? As there was friction here, the kinetic energy reduced and the kinetic energy becomes 0 here. The mass is still 2.4 while the velocity becomes 0 here. So what happened to this kinetic energy? Kinetic energy was lost. Why did it last? Because friction started acting like this, it had a displacement like this. So there was work done against friction. What is that you are going to do? You are going to find out what is the displacement, okay, and you equate the change in the kinetic energy is equal to work. What is this? This is your work energy theta, right? So change in kinetic energy. What is change in kinetic energy? This should be half mv square. Should be half multiplied by 2.4 multiplied by 2.16 square is equal to frictional force. What is frictional force? We just computed. It is 9.6 multiplied by s. Why? Because work done is force multiplied by displacement. Force is acting like this. Displacement is acting like this. I can get this. Hey, but you can say work energy theorem is final kinetic energy minus initial kinetic energy is equal to work done, right? So what is final kinetic energy? Final kinetic energy is 0. 0 minus initial kinetic energy is equal to so much. What is work done? Work done is equal to frictional force dot s. What is this now? Frictional force is acting like this. Displacement is acting like this. And thus what you get? This should be equal to frictional force displacement cos 180, right? Which should be minus ffs. Now write this is minus over here. So this negative goes away here. You can find out the value of s. So the value of s would now be equal to this. Lot of glitching over here. I don't know. It is a mistake. For a long time I'm using this laptop. What's wrong? Okay. You see. So therefore I get this as 24 into 2.16 square divided by this is 2 multiplied by 9.6. Okay. So when I do this, what do I get? This value. So you get this as 24 multiplied by 2.16 multiplied by 2.16 divided by 2 is equal to so much divided by 9.6 is equal to 5.832. I will take this as 5.8 meters. 5.8 meters. Okay, this is one method. There's one more method. What is that method? Since the acceleration here, acceleration of retardation due to friction is equal to mu times g. Okay, so you know this mu times g, which should now be equal to 0.4 multiplied by 10, which should be equal to 10. Sorry, this is equal to 4. It should be 4. So what I will do is, we know v square equal to u square plus 2as. You can use that one, and thus I can write v square equal to u square is v square is 0. V square equal to 0 is equal to u square. What's the value of u square? U square value is 2.16 square. 2.16 square minus 2 times as. What is 2? 2, I'll write this. A is nothing but 4. 4 multiplied by s. I can do it like this also. When I do like this, I get this as s equal to 2.16 square divided by 8. Okay. Let us do by this method also and see whether you get the same answer. If you get the same answer, then I am right. Okay. 0.16 multiplied by 2.16, correctly, divided by 8. I get this is 0.5832. 0.5832. Oh my god, what did I do? Times G here, right out first here. 0.58 meters. This should be 58 centimeter here. Okay, let us put this one there. Let's sit here. This 2.4, right? 2.4. I made a mistake right there. Let me just take it out. 2.4 multiplied by 2.16 multiplied by 2.16 divided by 2 divided by 9.16. Just a moment. See, get 0.611 there and here that's 60 here. Take the values of velocity properly. 2.4. Just a minute. 600. Frictional force is mu times n, right? Times n. 0.4 multiplied by 2.4 multiplied by 10. I took frictional force to be 9.6. This is right. And then times n is right. It should be half into 24. 2.4 into 2.16 square divided by 2. 2.4 into 2.16 square divided by 9.6. That's right. 2.16 2.16 divided by 2 divided by 9.6. 0.58. Got it correct. I made a mistake somewhere over here. So here also I get this as 0.58. So thus we have to get correct. Okay, so with this I think we have come to an end to this particular paper. As usual, look into the problem by working it out first, and if you still do not get it, then get the solution. Okay, thank you very much for being with me, and for the past 2 months I was not able to put any problems because I joined a new school and it was a bit hectic. I had to get adjusted with things, so a bit free. This is Diwali vacations. So, anyway, festivals are going on, but I still found some time. I hope I'll be continuing with this for the next 3-4 days. I'll be doing lots of recording and putting across all these problems. Let us see. We'll continue this. Thank you. Do like, share, and subscribe to my channel for more such updates. I think I would have gone through all my websites. The first one, my homepage, ratankar.com, has gone through a massive change. So many things have changed. And the second one, the IB Physics with Rao, also there's a lot of change over there. Earlier I used to have one vendor and it was not working well, so I had to completely scrap out the whole thing and then redo it once again. That's one of the reasons why it took such a long time for me, because I was all these days I was busy doing that. And the last one is prayogashala.com, and this had lots of simulations and so on. Hey, I also forgot to tell you that I have put across 3 apps which you can use it for designing your IAEs and TOs. Okay, thank you very much.